Okay, so welcome everybody to this session, and I hope the overall session will be useful for you. What I'm going to present is about cloud computing, the introduction of the cloud computing, the way I have recently discovered the cloud is actually used and is talked about in the industry, the research challenges and the future directions with reference to cloud computing. So as far as future direction is concerned, I'll be only talking about some specific portion that is directly related to the other directions. So I cannot cover everything, but I will just be talking about a very small portion. The objective of this talk is not to make people technologically rich or introduce a lot of new technology and a lot of new things that you do not know already. There are a lot of things that I will be talking about that most of you already know, have been using in one form or the other. So I'll just be revising those things. But how does all those things combine together to make one of the systems work in much more advanced way compared to the way we know? So that is the main objective. So giving a relatively advanced view of cloud computing that can inspire the viewers to push for the state-of-the-art research rather than doing whatever we are doing. There are a lot of things that we are already doing. So my objective is actually to move it to one level ahead. Okay, so with that, this is the sequence that I'll be following. I'll be talking about myself a little bit, then I'll be introducing the cloud computing. There are two different introductions, two different definitions. Present research trends, how the research is being done right now, what are the future directions of the research. And this is, as I said, based upon around my own knowledge. It's not a generic kind of cloud's future direction. So, about myself, first thing, something that I really want to do, something that I am good at, I believe, is to make practical systems that are usable. Generally, I do not enjoy the work where we can produce a lot of things, but generally nobody will use it. So throughout my career, this is something that I have strived for. So as far as cloud computing domain is concerned, for last 2 years, I am associated with this domain. Before cloud computing, I have made multiple systems that are used, that are deployed in the organization. All of them were related to networks. So my domain was, previously my domain was network. So for 2 years, I am working in the cloud computing. After 2 years, I have reached a point where now I can make something that probably will be useful, and that's what I'm going to do. So the ideas that I acquired by working on this cloud computing domain, some of them I presented to a group of venture capitalists. Venture capital, I hope everybody understands the term. The people who generally invest the money behind the ideas, and then they take a big share of the company, whatever you are going to make, because you don't have the money, so they provide you the money. But your idea has to be verified by them. So there was a small gathering of the venture capitalists. So I was lucky to be able to present my ideas. Actually, there was one of the research proposals that I submitted to University of Malaya. So one of the person, he really got interested, and so they said, okay, we're going to invest in this particular idea, so let's refine it, let's make it to the next level. So what's my deal with those people? Generally, the technical people are not good at sales and marketing, so they are going to provide me the sales and marketing expertise as well as the finances. This is one of the email experts. It's intentionally kept very small so that you cannot see. But this is where we are standing right now. We are able to, if you can see, the word somewhere over here. I don't know, somewhere. So the products that we are going to make, the first customer that we are going to target is Dell. Because Dell is making the system, so we are going to give our software technology to them. I will talk of what I am planning to make in a little bit of the detail. Okay, so with this, that's my qualification. That's why I am presenting what I am presenting today. That makes me stand at this particular place. So, how do we know cloud computing? Because everybody over here is more or less related to cloud research in one way or the other way. So, what is the most commonly used definition of cloud computing. This is the definition that we most of the time use. So clouds are resource-rich computational infrastructures. Virtually, we have infinite resources available. The resources are generally compute resources and the storage resources. And the resources are available as software as a service, platform as a service, infrastructure as a service. So I'll ask a quick question specifically those people who are related to cloud computing domain. How many of you agree that 90 or 95% of this definition is correct? Okay, so generally we are using this kind of definition. However, anybody who has deployed a cloud, anybody who has used a cloud, anybody who is in any way associated with a cloud knows that this definition is not correct. Okay, so the main problem, I will just ask a simple question. Has anybody seen a virtual machine instance that he was able to create on his own cloud, or he was able to get from somebody else? Amazon, for example, has one of the very well-known cloud services. So, was anybody able to create an infinite resource instance on Amazon server? Generally not, because that's not possible. The largest instance, as far as database is concerned, that they provide, I recently had an interaction, is 1 terabyte of space at the cost of $10,000 per month. How many of us can actually create 1 terabyte storage capacity for a database at our local storage? That's very easily doable. Now 1 terabyte hard drives are available and you can do that at home. Okay, so there's nothing special about this infinite capacity as far as cloud is concerned. Okay, so something else goes in the cloud. Some part of this definition is true. Mainly, if cloud can provide infinite resources, we will not need supercomputing, because now the problem is solved. Recently, we had one of the professors from Jordan University who spent a lot of time in United States. So he was talking about similar things. That this idea that people are switching over cloud has infinite resources is going to create a lot of problem for them because they don't have infinite resources. So just to give you a comparison between cloud computing and supercomputing, in the cloud we have something like this. There are a number of computers that are combined together, linked together to provide a computational capacity. Whereas in the supercomputer technology, something like this is being made. This network connection, probably 1 gigabits per second connection, which has a bandwidth of 40 gigabits most of the time, is actually being improved to something like this. Instantaneous transfer from one device to the next device. You don't even need one memory cycle. This is the Sun architecture presented by the same person that I just mentioned. Okay, so what Sun is doing, this is part of their proximity computing which goes into their servers. So the data that is available over here, you don't need duty cycles to copy this data into the receiving device. It will automatically, there is an overlapping motion and it automatically gets copied from memory to switch, from switch to the process. That communication is taking place automatically. So if we say that the cloud provides infinite capacity, what we are saying is that this cable is faster than this transfer, which we know is not true. So generally clouds do not have infinite capacity. So what do clouds have? Basically, the goal of the cloud computing is to apply traditional supercomputing or high performance computing. So at the back end, you can have supercomputers, you can high performance computing resources. And normally, those resources were previously available to the military, to the research facilities, and recently these kind of resources became available to the people who were performing very complex tasks on the data, for example, the engineers working in Google. So we're going to use these computational resources that can perform trillion of computations per second. And what do we do in the end? In a customer-oriented application such as financial portfolio. I have a database at the back end, I have some financial transactions going on. So that application will now run on this kind of facilities. And that's not the only application. There are thousands of similar applications that are running on that supercomputer. So you get a portion of that supercomputer. Okay. So out of this entire thing, this is a supercomputer. This is the second fastest supercomputer. supercomputer available in the world. That's what all the data centers look like. Okay? If the data centers look like this, if some data center purchases this thing at the back end and they deploy a cloud operating system on this one, I will probably be getting something over here. Maybe not even visible. That processing power will be available to me as a user when I will be performing high portfolio computations and when I will be paying something like $10,000 or above per month. Okay? So, these supercomputers are not available to everybody. They are not at the back end. What is at the back end? This is at the back end. So, the same continuation of whatever was written on the previous slide. So, to achieve that superpower kind of computation, they don't deploy the supercomputers. What they do, the main point because of the slide is that low cost consumer PCs are used. Okay, so we cannot reach infinite capacity, we cannot reach supercomputer kind of capabilities, we cannot replace high performance computing when we are doing cloud computing. Okay, so that is what the clouds are not. They are not supercomputers, they don't provide infinite capacity. So what actually the clouds are? So if we talk about that, this is what the true clouds actually do. It's a set of softwares. The hardware was already available in the data centers. So there's nothing new as far as hardware is concerned as in the clouds. The difference is with the software. So what part is different? Cloud computing is a general term for delivery of hosted services over the internet. Whenever you deliver hosted services through internet, that thing will be called cloud. So most of us are already doing that. An email server is there, it is being delivered through internet. So now this new name has been given and there is a reason why the new name has been added. So cloud computing enables companies to consume the compute resources that they have not deployed, rather somebody else has deployed and they start using it as a utility. Okay, so that is where the terms in the previous slide, platform as a service, software as a service, and infrastructure as a service come. I don't need to purchase the computers for myself. What I do, somebody has purchased, somebody has set up that system. Let's say I am a startup company. And my application that I want to develop is a compute extensive application. It performs trillions of computations per day. Now I cannot start my company without purchasing that kind of infrastructure and without purchasing that kind of IT mechanism if clouds are not available. So what clouds are providing? Okay, we have this trillions of computational capacity, trillions of flops capacity available to us. We can do your transactions, no problem. You don't have to establish, you don't have to hire the manpower. All you do is you start your own business, your own part, write your own application. So in this case, I will be hiring 4 or 5 people who will be developing my application and I will upload that application onto a cloud and then trillions of dollars of computational capacity will be available. More or less, I will still be paying the same amount, but on a monthly basis, which I can do. It's like mortgaging your entire infrastructure. This is easily doable. This is true not only for a startup, only for any business. I am a bank and my main job is to do the transactions. So I don't understand this technology, IT at the back end, and therefore I will replace that technology using the cloud as a service. So that's where this utility thing comes in. But then there is an issue. There was a term before clouds that was called utility computing. So utility computing was already there. So what's the difference between the utility computing and the cloud computing? Actually, everything that is different between utility computing and cloud computing, that's what the clouds are. Those people who will be going through this deployment of the cloud are those who have already interacted with the clouds and try to deploy their own clouds. They will see that actually it's the resource management. That's the main thing that the clouds provide. Virtual machines were already there. Virtualization software were already there. VMware is there long before actually the clouds came to being. Okay, so we can do this virtualization and everything. The issue is, I want to create 100,000 virtual machine instances in one go. Using VMware, that was not possible. Okay, some people write some scripts, so that scripts now go into the cloud. They will do this task automatically for you. Point number one. Point number two, when those virtual machines are created, the next thing that comes is how will we provision them? Which physical machine the virtual machine will go on? How will we bill the person? If a person has not paid, how will we stop the instance of that person? How will we ensure that the service level agreements that we have established with the people, those agreements hold? All these things are management aspects. The clouds provide this management aspect. On top of, as I said, Zen, VMware, Anjum, on top of virtualization technology, which was already available, which was already providing platform as a service, infrastructure as a service, and software as a service. So we are providing management on top of it, number one. Number two, we have elasticity available to us. The normal virtualization technologies, they will provide you the computational resources, but you cannot expand them or shrink them on the fly. Okay, so that's what the cloud is going to provide you. Again, a management aspect. So increase your computational capacity in the virtual machine, part one. Part two, I am having a specific cloud established here. For a few days, I have extra customers coming to me. So what do? One of the options, I purchase new hardware, install it to my cloud, get it to work. The second option, I don't need to do this. I have negotiation mechanism with an alternate cloud that is deployed in an area where relatively lesser computational power is being used. What I will do, I will get the computational power from that organization, that cloud. When my requirements are gone, I will terminate that. So, being a cloud service provider, I am also a customer of one of the other cloud service providers. Okay, so this is something, this is called elasticity in the cloud. The resources by the service provider as well as the consumers can be expanded and can be shrink based upon the need. This is something that is unique about the cloud that is not there, so the cloud software provide this particular functionality. Okay, so final thing, the clouds can be privately owned. Okay, unlike data centers that I cannot own unless I am spending a huge, but the clouds can actually be deployed at my home. I can have a very small cloud, I can have a very big cloud, that will facilitate me to manage the resources. Okay, so these three things make it different from utility computing. Anything that is built above the utility computing is known as the cloud computing. So that is how the clouds are generally known. I come to the third part of the presentation. What are the research challenges when we talk about clouds? Okay, so this is actually taken from the conference call for papers. So these are the issues that we are generally addressing: the cloud application scalability and availability. Many of these issues are very current. People are working on them. So this is one aspect, one view of cloud computing. So for example, cloud application portability. If an application is available in one cloud, how can we port it to another cloud? If an application is by default not a cloud application, how can we port it into a cloud application? Cloud virtualization technologies, QoS for applications of the cloud, and so on. So I'm not going to go into the detail because everybody knows this particular part. We have submitted the papers on this and we are working on this one. This is the different view. What the giants, heavyweights are doing in this domain. This is the present research that is going on. I have taken 2 or 3 different samples. So the document is as recent as 11 December 2015. Okay, so this portion comes from Google Research. Distributed balanced partitioning of the clouds. Okay, this is something that they are working on. Can traditional programming bridge the ninja performance gap? Developing the programming tools. Okay, this is what they are working on. And if you note, the image is not very good, but 2016. This is the last 2016, still to be presented. Okay, so this is what the heavy weights are doing. Going back to that particular portion, this is from Microsoft Research. So one of their scientists recently got the special invitation to be the IEEE Fellow. So what he has done, storage, where is storage? Okay, so networking and data storage. With reference to clouds, we are not talking of data clouds, we are not talking of big data. When we are working inside the cloud, there are a lot of data issues. I will talk of a few of them in the next portion. Similarly, there are a lot